This class we worked out on problem on series resonance circuit. This is the given circuit. The resistor, inductor and capacitor all are connected in series. Supply voltage is 200, frequency is 50 Hz. Calculate current, impedance, voltage across the resistor, voltage across the inductor, voltage across the capacitor. In the same problem, calculate the resonant frequency and calculate impedance, current, voltage across the resistor, voltage across the inductor, voltage across the capacitor. Draw the phasor diagrams. That is the question. First we will take 200 volts 50 Hz. XL is equal to 62.83 ohms. XC is equal to 21.22 ohms. Impedance Z is equal to 46.17 ohms. Cos theta is equal to R by Z, that is equal to 0.433. Theta is equal to 64.34 degrees. Current I is equal to V by Z, 4.33 amps. Voltage across the resistor I into R is equal to 86.6 volts. Voltage across the inductor I into XL is equal to 272.054 volts. Voltage across the capacitor I into XC is equal to 91.883 volts. Now VL minus VC is equal to 180.171 volts. Voltage is equal to root of VR square, voltage drop across the resistor square, plus VL minus VC the whole square. That is equal to 199.90 volts, almost equal to the supply voltage. This is the phasor diagram. Here this is VC, this is VL minus VC, the angle 64.34 degrees, the resultant voltage is 199.90 volts. Current is 4.33 amps. Next I will calculate the resonant frequency, that is 1 by 2 pi root L into C, that is equal to 29.07 Hz. Now I calculate XL. XL is equal to 36.53 ohms. XC is equal to 36.50 ohms. Z is equal to 20 ohms. At resonance, resistance value equal to impedance value. Here 20 ohms. And then resistance value is 20, impedance value is also 20. I is equal to V by R, that is equal to 10 amps. Cos theta is equal to 1, theta is equal to 0. Voltage drop across the resistor is equal to 200 volts. Voltage across the inductor is 365.30 volts. Voltage across the capacitor is 365 volts. VL minus VC is equal to 0. Therefore, voltage is almost equal to the supply voltage. Now we will compare the result. Here frequency is 50 Hz. Here frequency, resonant frequency 29.07. Here the current is 4.33 amps. Here the current is 10 amps. This is the phasor diagram. Here VL is equal to VC. The resultant is 0. Therefore VR is in phase with the current. Current is 10 amps. The impedance is 46.17. Here the impedance is 20. You get the maximum current 10 amps. The voltage across the resistor is 86.6. When frequency is 50 Hz. At resonant frequency, this is 200, almost equal to the supply voltage. We will get the maximum voltage across the resistor. Next, power factor is 0.433 when frequency is 50. At resonant frequency, this is 1. Angle between V and I is 0. Here 64.34 degrees. Now we will calculate I square R. Here I square R is 375 watts when frequency is 50 Hz. When frequency at resonant frequency 29.07, I square R is equal to 2000 watts. Okay. Problem 2. A resistance, a capacitor and a variable inductance are connected in series across 200 volt 50 Hz supply. The maximum current obtained by varying inductance is 0.315 amps. The question is, calculate the circuit constant the voltage across the capacitor is 300 volts. We know that maximum current occurs at resonance is V by R. Voltage is given 200. The current is 0.315 amps. So V by R is equal to 0.315 amps. I can calculate R is equal to 200 by 0.315. That is equal to 634.92 ohms. That is the value of resistance. Next, voltage across the capacitor is equal to I into Xc. Capacitive reactance Xc. That is equal to 300 given. I can calculate Xc. Xc is equal to 300 by 0.315 current. That is equal to 952.38 ohms. That is the capacitive reactance Xc. Now I can calculate Xc. Xc is equal to 1 by 2 pi Fc. I know Xc. I know frequency. I can calculate capacitor C. So capacitor C is equal to 3.34 into 10 power minus 6 farads, or C is equal to 3.34 microfarads. The last is I have to calculate L, inductance. You know that resonant frequency is equal to 1 by 2 pi into root L into C. I rewrite the equation Fr into 2 pi is equal to 1 by root LC. I square both sides, Fr square into 4 pi square is equal to 1 by LC. Now I can calculate L. I know capacitor value, I know the resonant frequency. So L is equal to 3.034 henries. So the circuit constants are R is equal to 634.92 ohms, L is equal to 3.034 henries, C is equal to 3.34 microfarads. This way we have to calculate the circuit constants. With this I conclude my lecture. Thanks for listening.